Good morning. நம்ம இப்போ பார்க்க போகிறது வந்து ஸ்டேட் வேரியபிள் ரெப்ரசன்டேஷன். State variable can be represented in various forms. நம்ம ஃபஸ்ட்டு பார்க்க போகிறது வந்து ஸ்டேட் வேரியபிள் ரெப்ரசன்டேஷன் பை ஃபிசிக்கல் வேரியபிள்ஸ். நம்ம இதுக்கு முன்னாடி ஃபஸ்ட்டு கிளாஸில் சொன்ன மாதிரி ஸ்டேட் வேரியபிள்ஸ் is nothing but it actually determines the current state of the dynamic system. It actually determines the current state of the dynamic system. Normally, energy storage elements are chosen as state variables. For example, in an electrical system, current through the inductor and voltage across various capacitors are cited as state variables. In general, the physical variable associated with energy storage elements, which are responsible for the initial condition, are cited as state variables. Before going to the problem, one must know about the state model as we mentioned earlier and about the various dimensions of the matrices. That is A matrix, B matrix, C matrix and D matrix. One must be thorough with the equations. This is problem number 1, which is a simple problem. In this problem, they are asking to obtain the state model. State model means we have to obtain state equation and output equation for the given electrical network. In this given electrical network, we are having the basic elements as resistance, inductor and capacitor, and there is a current flowing through the circuit. As the diagram shows, there is an input and there is an output. Input is VI of t and output is the voltage across the capacitor. See, in this circuit we are having two energy storage elements. Inductor can store energy and capacitor can store energy. Therefore, there are two state variables. One is current through the inductor can be chosen as state variables, and voltage across a capacitor can be taken as state variables. As we already know, state variable matrix is nothing but x of t. This is a column matrix. We have x1 of t as one of the state variable, x2 of t another one of the state variable, x3, x4 and goes on depending upon the number of state variables. Here we are choosing two state variables, therefore there are two state variables, x1 of t and x2 of t. x1 of t is I of t, that is the current flowing through the inductor. x2 of t is nothing but V of t, which is the voltage across the capacitor. And as we already discussed, in state space representation, input is taken as u of t, where in our case it is the voltage, and y of t as the output. Now coming to the state model, see, x dot of t is a column matrix. This x dot of t consists of x1 dot and x2 dot. First of all, we need to find the state equation. Then after finding the state equation, we will find the output equation. Now to find x1 of t, we must apply KVL to the given circuit. If I take the given circuit, Kirchhoff's voltage law, input voltage is equal to sum of the voltage drops. For input voltage is VI of t, that is equal to the voltage drop across the resistance V is equal to I into R, that is the current is I of t and R, plus voltage across the inductor is given by L into di by dt, plus voltage across the capacitor. Thus, across voltage across the capacitor, this voltage across the capacitor here it is V0 of t. This representation is a physical representation. Now we have to transfer the physical variable notation into a space variable notation. Since V of t is taken as U of t, V of t can be transferred as U of t input, I of t is transferred as x1 of t, and di by dt is transferred as x1 dot of t, and V0 is transferred as x2, as we already mentioned. From this expression you have to find x1 dot alone. Therefore you must send these parameters to the left hand side, and you know that is a basic mathematics. From this we can find x1 dot. Similar way we have to find x2 dot. To find x2 dot, we are taking voltage across the capacitor. We already know that voltage across the capacitor V0 is x2. If I want to find x2 dot, I must differentiate this V0. As we already know, the voltage across the capacitor is given by 1 by C integral I dt. If I differentiate this, I need to differentiate this one. Therefore, this integration will get cancelled. Therefore, the final expression is x2 dot is equal to 1 by C x1 of t, where this I of t is written as x1 of t. We have given here. We have got two equations. This is equation number 1 and this is equation number 2. We have x1 dot, x2 dot. From this, these two equations are rewritten as in the matrix form. x1 dot, x2 dot, that is equal to, this is the A matrix, this is the B matrix.